Surface area of a cone, max. This is 8.4.
Cone is a familiar shape to most people. Most of us learn about this shape as children when we eat an ice cream cone or a snow cone for the first time. As with a pyramid, the height of the cone is the perpendicular distance from the vertex to the base. The slant height of a cone is the distance from the vertex to the point on the edge of the base.
All right, good. So we've learned a few definitions here. One is a cone, three-dimensional object, circular base, and curved lateral surface that extends from the base to a point called the vertex. So the most traditional cone is the ice cream cone. Okay, remember circular base, so it's like a cylinder, but it comes to a point, right? A couple of important definitions here. Slant height. So that's the height or the length of the edge of a cone. So from the vertex to an outside point on the base of the cone. Okay? Straight height, again, is perpendicular, so right from the base to the very point, top of the vertex. Okay? And then base and vertex, obviously, we should already know. Okay, let's jump to the problems really quickly here. We're going to skip through this investigate to save a bit of time. We're going to go right to the problems here. You can use proportional reasoning to find the lateral area of a cone. The ratio of the areas is the same as the ratio of the circumference. So the lateral area of a cone over the area of a circle is equal to the circumference of a cone over the circumference of a circle. We're going to explain that a little more before we actually see the equation here. So let's just go through this, and at the end of it, we're going to see that our equation looks like this, and I'll explain that. So consider a cone with a slant height S and a base radius R. So we can see that cone here. Here's our radius. We know it's from the base, from the middle to the outside, and our slant height is S. Okay? The circumference of the large circle is 2 pi S, and the circumference of the base of the cone is 2 pi R. So the base of the cone, 2 pi R, and the large circle is 2 pi S, S being the slant height. The area of the large circle is pi S squared. Substitute into proportional reasoning. We can look at our equation here that we've talked about over here. A lateral area of the cone over the area of the circle is equal to the circumference of the cone over the circumference of the circle. We substitute in those formulas that we've already derived, and we end up with the lateral area of the cone being pi RS. So who can tell me again, what do I mean when I say the lateral area? What does that mean? It's important. If we don't know what that definition is, then it's going to be a hard time finding the equation. Yeah, Vatri.
It's the area that's not the base.
Right, exactly. So the area, basically, the whole other surface area, that's not the base. It's the slanted sides of the cone, okay? So the important thing here, the takeaway here, is that the surface area of the cone is equal to the lateral area plus the area of the base, okay? So pi RS plus pi R squared. Okay, pi R squared being the base. So let me ask you this. What would be the formula for an open face cone? So therefore, there's no top on the cone. What would be the formula for surface area of a cone with an open face? Sal? Yeah, no top, no base. So just like an ice cream cone, there's nothing on top, right?
So it's pi R S plus pi R squared.
No, that's for a cone with a closed base. You got it. Look at this equation, right? Look at the two parts.
Yeah, is it pi R S plus pi R squared subtract the base?
No. Yeah, well, yes. What would you get, Steven?
Just be pi RS?
Yeah, it would just be pi RS, right? If there's no base, you wouldn't add the base, okay? Max?
So wouldn't it be times 2 because it's open faced?
What would be times 2?
If you want to find the total surface area of an open faced cone, because you want to find the outside and the inside.
Yes and no. I guess we're not considering the inside surface areas of any shape. We're only considering surface area to be the outside. And I understand where you're coming from because you're saying, well, it's open, so now you have an inside surface. But if it's just one piece of paper, right, you wouldn't consider, surface area to be, even though this is an open cone, right, I'm not going to consider this and this to be two separate things, right? If they were, there would also probably be an edge you'd have to consider, like a thickness edge, and we're not considering that, okay? So I guess to your point though, the question might be, what is the outside surface area of an open face cone? Okay, but good logic. I understand where you're coming from. Alex?
Oh, how would you find the radius of the cone or whatever if it didn't have like a base?
The radius?
Yeah.
It might tell you anyways. It might say the distance from this edge to this edge of the cone is this, okay? But you're right, if it didn't tell you, if it didn't have a base, it might be difficult to get, but we'll see an example now. Surface area of a cone. So we're going to calculate the surface area of the cone to the nearest square centimeter. So we have two pieces of information here. We're told that the slant height, we don't know the slant height. Looks like we know the height and we know the radius. Everyone see that? So in this cone here, we know the height and the radius. We're going to use Pythagorean theorem, if you can see this triangle here that I'm going to create. And what is this hypotenuse going to be equal to in terms of definition of our cone? Justin?
The radius is going to be the hypotenuse? Or
No.
The slant is going to be that.
Right, our slant height. So our hypotenuse is equal to S, or our slant height. Okay, and how do we find that? Again, using the Pythagorean theorem. This time it is the hypotenuse, so it's on the left-hand side. S squared is equal to 8 squared plus 3 squared. We solve for S. S is 8.5. So there's our slant height. Once we have our slant height, that's the only unknown that we need to substitute into our surface area equation. So pi rs plus pi r squared. Okay, so r is 3, S is 8.5. Not solved for. Any questions there? And we just work that out. Here it's showing you on your calculator the buttons you would actually press. Any questions? Okay, our surface area ends up being centimeters squared. Key concepts now, very quickly. The surface area of a cone consists of a lateral area and an area of the circular base. That's why there's two parts to the formula. Pi r squared is the base plus 2 pi rs, which is the lateral surface area. The lateral area is formed by folding a sector of a circle. The radius of the circle becomes the slant height, S. So can you guys visualize what's happening here? Do you see how this is like a cone cut open? If you were to cut a slice into a cone and unfold it. See, there's the sector. You guys understand how that's working? The radius of the circle used becomes the slant height, S. That's S, that's your slant height, that's the radius of the circle of the cone formed. The area of this curved surface is pi rs, where r is the radius of the base of the cone. Tyler?
So does the size of the sector affect the size of the slant height? So the greater the sector, I guess?
No, the sector, the S is going to be the same all the way around, right? Because it's the radius
Okay.
of this particular circle.
Like what I'm trying to say is like the bigger the slice you take out of that cone, like, you know what I'm trying to say? No?
No.
It's like the space of the sector if it was smaller with the slant height and doing that.
No, it's going to be the same because the center is going to be in the same spot. The area of the circular base is pi r squared. We know that, area of a circle. The formula for the surface area of a cone is surface area of the cone equals pi rs plus pi r squared. That's the important thing. That's the important takeaway here. That's all we're looking at, surface area of a cone. When you know the radius r and height h of a cone, you can determine the slant height using the Pythagorean theorem, which we did in that last example. Any questions with that one?